watch the recording again and again. So yes, here we are. We just started. Hi Berzan, hoş geldin, welcome. So yes, I guess we can uh, slowly start. Lawrence, do you have anything?
Yeah, I can make a start if if you're ready.
Okay. Okay, so we are ready. So
Yeah.
thanks, guys. Thanks for coming here. Today we are going to have these Mina Navigators Learn-to-Earn development workflow, design approaches, techniques, and useful patterns um, lesson here with Lawrence Kirk as always. So I'm just passing the word to Lawrence, and I hope that it's going to be a nice session. Thank you.
Great, thanks. Hey everyone, yeah, I hope you're having a good day. First of all, sorry that I had to postpone from last week. I was ill, so I do apologize. Hope I didn't cause any inconvenience to people. Let me share my screen and then we can make a start. Okay, yeah, I think you can all see that. Okay, so yeah, so the second of these sessions, so we're going to talk, it's perhaps a little bit more abstract or more general, I suppose. We're talking more about development in general and techniques and patterns, that kind of thing. So it's we're kind of saving some of the more detailed work. Certainly we'll be doing more of that next week, although I think next week we're going to talk about recursion, but I think we'll probably also cover some more useful techniques as well. We'll just kind of keep those going throughout the sessions. Okay, so yeah, what we're going to talk about, we'll start off with what's new, because I haven't seen you since, well, I guess before Christmas. So yeah, well, Happy New Year, everyone. I should say that. So we'll talk about what's new. Then we'll go into the details of development. So I think this should be familiar to most people, but it's worth getting these pieces together anyway, and making sure it's clear. And then we can look at different techniques and useful patterns that I've found. There's a link there to the Slido, so please use that. It's we have two parts to that. There's a poll where you can put in any topics that you would like us to talk about. There's also then the Q&A part. So make sure you if you're going to post, put it into the correct part so it doesn't get missed. Yeah, so if you have questions, please put them in the Q&A. I know there were some questions about the challenge, and I do apologize. I missed these things on Discord. I guess my notifications, I must have set them up wrong. So I do apologize that I missed some of those. But please, if you do have questions, you can put them into Slido, or also you can DM me as well. That's all fine. I did notice one person had put in some questions, so I'll just go over those. I think they were. I think these will probably other people will probably have the same questions. So one of the questions was there was a part that they thought was open to interpretation, and they were asking what to do about that. So generally with the challenges, they're not meant to be tricky in any way. They're not meant to catch you out. We want these to be really to make sure that you've just experience of different aspects of the language or different features of Mina. So certainly if something looks wrong, and certainly if I've said something that is impossible to do, I do apologize in advance. I think it's okay, but yeah, if there's something that is not possible, or you think you need to do something in a certain way, then I'm happy for you to interpret it like that, as long as you're you're making an effort to sort of follow the spirit of the thing and work on the particular area. I don't think that's a problem at all. The second part, the question was, could we make assumptions about access to various data structures which may not be entirely on chain? So from that, what I would say was, if you look at the the challenge and the kind of the use case, you would see that there's just a couple of people involved who would be setting up these data structures, and then some of that information they wouldn't want to share. So I think hopefully from the context of the challenge, you'll be able to see which bits will be open to the public and which shouldn't be. So I hope that answers the question, but yeah, please do ask further or DM me otherwise. The question about making the repos public, I'm not sure about that. So I'll get back to you on that. I'll need to ask, I guess we'll ask Will about that. For me, it doesn't matter to me, but yeah, I'll check before I give you a definitive solution to that. Okay, so I hope that helped a little. I know someone else also asked a question. There was I'd written something saying to pass a parameter to a function, and they were saying, could they have more than one parameter? That's okay. Sorry if it's, I think the way I'd worded it was perhaps more restrictive than it necessarily should have been. So yeah, please do, do it in whichever way is going to work for you. Okay, so that's the that part done, the challenge, and we'll come to that. And we've got the next session next week, the recursion session. Then we've got, after that, we've got a session to go through the challenge. So we'll do that at the end of the month. So today we're going to, look at various techniques and useful patterns. I have, for this, I have, looked through pieces of code that people have done and drawn in lots of different examples that I hope you will find useful. But, I am very grateful to the people who have done this code. Often, the people who've made a breakthrough in a particular area and really push things forward. And I don't want to belittle what they've done at all. I mean, what they the community and the way that people are pushing this forward is amazing, and I really am grateful to them. So thank you to everybody whose code I'm going to be demonstrating in this particular session. I am very grateful. There's some really impressive things that people are doing. I very much feel that we're standing on the shoulders of giants at times with some of these things. So thank you to the people who have done those projects. One aspect of the Navigator sessions generally, and I think it particularly applies today, is that we appreciate that in this, in the Navigator scheme, that you're working on your own project, and which is fine, obviously, but this does mean that you're very focused on a certain use case and a certain way of doing things. And what we would like to do, one of the ways that I think this is going to be beneficial to you, is if we can try to introduce you to areas that maybe you haven't been using in your project, or just to broaden your experience of what other people are doing. So that is really the approach that I'm going to try to take, particularly today, to try to give you an idea of the other things that are happening out there. And this is so that maybe this will help you with the project you're working on, and maybe you'll find some useful techniques to solve things that you're trying to do, or maybe you'll find some functionality that you can add to your project. But also, hopefully it'll go beyond that. And if you then work on another project, maybe this will inspire you or just give you an idea of the kind of potential that there is. I think certainly with Mina, we're very fortunate in that these are still fairly early days, and it does feel like this is very much greenfield site that we have, that there's a potential to go out and really choose the types of things that you want to build, and that is a great opportunity. So yeah, I definitely encourage people to make the most of that, to go out and try things out, and really explore the ecosystem. There's certainly a lot that can be done. So I hope this is going to help you with that. Okay. All right. So so what's been happening? So there's the blog there linked to tell you about various updates. Some of these I think we talked about last time. So I did talk about some bitwise operations last time. We've also got foreign field arithmetic. I'm not going to go into that today. We can go into it maybe another time, maybe next week if people are interested. But the idea behind this is really it's kind of an interoperability, I suppose, and allowing you to work with other systems and to use the data types other systems have, and allow you to work with integrate other pieces of code into your code. So that's what that is all about. And this certainly is not something new to that Mina started. You see this in many different languages. They will support these types of things because it's realized the languages, there's great benefit for languages to be able to talk to each other and interoperate. That idea of interoperability on perhaps a more general level comes into the next couple of points here, where this is very much about integration with the Ethereum blockchain and the particular cryptography that they have used. And this is bringing the Keccak hashing scheme and the ECDSA, the signing scheme, signing algorithm, bringing those into Mina. And it is, in some ways, you might think this is a backward step in a way, because I think it's fair to say that Ethereum, when it was created, it wasn't necessarily very ZK friendly, and so the types of projects and frameworks that people have built since then have been using different hashing functions, for example, which are more ZK friendly. But it does make sense to have this these schemes, these functions available, because there is interoperability with, for example, with Ethereum, and so this helps with that. The next point, I don't know why it hasn't got a dot, but anyway, there was a massive improvement in improver times. There's links there to details about this. The gist of this, what happened was that it was realized that sort of some existing data, some structures, I think, were being rebuilt unnecessarily, and that they could be cached and reused, and this would make a massive difference. So yeah, that's a great improvement. And yeah, if you want to find out more, there's more details there in those links. Interesting things coming up. Just one thing I picked up is that an improvement to the way circuits will work with some asynchronicity being involved. So that should help further help the performance. So yeah, and there's a link there to the details about that as well. There's a link there to the Mina roadmap. Always good to keep an eye on this to sort of see where we are. Let me can I zoom? Yeah, I can zoom in. I think we spoke a little bit about this generally, but yeah, it's worth having a look. Oops, at what's coming up. Yeah, so do keep an eye on that. Certainly, it's worthwhile keeping this in the back of your mind, so that when you're building your projects, there may be some technology that you're going to be able to make use of that's coming up. So do take a look at that. All right. I just also wanted to talk a little bit as well about general directions in blockchain, because although Mina is just to some extent very much its own master, and I really, this is one aspect of Mina that I've always very much enjoyed, that in some ways they've got their vision and they're following this, and they're not, I don't think, as influenced perhaps or swayed by some of the other trends in blockchains, but still we do have to be aware of these. And what we're seeing, I think, is certainly moving to more modularity, and I think that this is, Mina can also benefit from this. The idea that different concerns could be, or different features of blockchains could be handled with different chains. So that things like, say, data availability. And we'll perhaps come on to that a little bit more in the next couple of sessions, the way some of the projects that are building and sort of building on top of Mina. So, but that's just worthwhile sort of bearing in mind, I think, generally for the where things are going. I think there's still a focus on scalability, and that's been something that people have wanted for, the kind of the throughput and sort of low fee idea has been something that people have been wanting, and it's going to be, a continuing desire for people using blockchain. Mina obviously has different ways to approach this, and so they're perhaps less swayed by this. I think this is more with other chains, but what we are seeing with other chains, which is very much concerns Mina, is the idea of privacy, and I think there is beginning to be a movement towards this. I think this perhaps is because maybe other things have been solved to some extent, such as scalability. There's been improvements in that, and so this has given people the opportunity to start to think about things like privacy. So that's going to be very interesting, and I think we're going to see more use cases, and obviously Mina is very much poised to take advantage of those. So that's very good. And then, interoperability. So I just see this increasing generally, and people benefiting from this. So I've got a link there to the Mina, the bridge to Ethereum that is being developed, and I imagine there's just going to be we're going to see more and more of that over time. That people will build projects to link these things together. A question about the subcurve, like maybe job. Okay, on the past curve. I don't know the answer, but I'll try to find out about that. So you're looking for elliptic curve operations. Okay, I'll see what I can find. Okay, so let's just talk quickly about the general development workflow. I mean, I suppose this is really obvious, but as developers, we have this loop that we're in, developing our project, our code, and we typically, well, maybe you're an absolute genius and you can write perfect code first time and it will work and you don't have to change it. Well, my hats off to you if you can do that, but most people, we have to go around this loop where we start off, we write some code, we then test it, we realize that there was something wrong, so we rewrite the code, or maybe we realize that the test wasn't sufficient, so we rewrite the test, and we go round and round this loop. And it makes a lot of sense to make this loop as small as possible because of the number of times you're going to be going around this loop. So to maximize or to get the most out of your time, you really want to make this as efficient as possible. So let's talk about some of those aspects. One thing I'd like to talk about first is around testing. Now, I suppose most of you have come from probably a Web 2 background and moved into Web 3, and certainly the general ideas and the principles around software development that you will have learnt in Web 2, I mean, they still apply in Web 3. You can still use those types of techniques, but there may be additional things that you would want to do. So things such as test-driven development, still can be advantageous. I'm not going to get into a big argument. I know some people like it, some people don't like it, or whatever. But those types of approaches, whatever approach you're comfortable with, obviously you can still follow those. So things like getting coverage reports, making sure that your tests are covering all of the logical paths within your project. That still makes sense. You should still be doing that. And while I'm talking about this, perhaps I should, I suppose I'm speaking here now as from my auditing experience, where I would say when you're writing tests, what developers tend to do is to, they'll have a certain piece of functionality that they want a function to produce, and so they will write a a test and to make sure it does that, which makes sense because that's you have to get that functionality out. That's what your manager wants you to do or whatever. But so that makes sense that you want to do that. But it's not sufficient to leave it there. You really, when you're testing your code, you should really be trying to break it. And if you take that type of mindset, you will certainly, I think, do really benefit, really improve your code, make it much more secure. So please do try that. Do try to do your utmost to break your own code, and also get if you can get other people to get their eyes on your code and to try to break it, it makes sense as well. So lots of unit tests, integration tests make sense. Because we're using TypeScript, JavaScript, then there's lots of support out there, such as the Jest framework to help you with tests. There's a link there to the documentation. If you're new to this, then typically what you do is write these describe blocks around a particular area of functionality, and that's good. It sort of separates things out. It's also good for other people who are looking at your code. It makes it more obvious what your code is doing as well. And also we have the usual, before functions as well. And yes, you should be doing pre and post checks on the state of your code as well. The test matches, yes, let me get back to that. Yeah, I should have put some more detail about that. So yeah, thanks for that question. Sorry, this question on Slido about that. I'll update this when we meet next week as well. Go through that. One thing that you probably would want to do when you're running your tests, because the testing process, you're moving from what you're doing. Initially you're probably just testing a piece of logic to see that the logic you've written makes sense. And as part of that, you may not be as concerned about the proof being produced. And so there is this option, you've probably come across it, to allow you to disable proofs. There's a parameter that you can use when you're setting up your local blockchain. You can also set it later as well. So do that again, it helps you go around this, or helps you when you're going around this loop, to make that as fast as possible. Of course, there is going to be a progression of how you're doing your testing. So unlike in the Web 2 world, where it may have been sufficient for you just to test something locally, in Web 3, obviously we have this additional thing of there's a network where the code is going to be running as well, and we're going to be interacting with other pieces of code. And so although you're going to start out running something locally, you're then going to want to move once you've done the testing and made sure that the functionality is there, that your logic is correct. Then you're going to want to move on to different types of tests and to deploy onto different networks. So the next just pieces here are just talking about that progression. So you can start off with this mock blockchain that is just there to allow you to run your code. There's some example here. I'm sure you've all know this. And then once you've done that, then you can, if you want to then look at sort of the wider context, then you can run there's a Docker image to run up a local network. Again, all of these things have pre-funded accounts, so that's useful, and you can set up, have different options around that with how many nodes you have. And then you can move on to test networks as well. To help you with this, there's the zk config. Sorry, that should have been in sort of in quotes, I guess, to allow you to set up the configuration for this. So it's when you're thinking about this whole development process of testing and deploying your code, it makes sense again to automate as much as possible. So again, you're reducing the amount of time that you have to spend on this. And so with this, and also to help you make sure you're not making typos and to reduce the amount of cognitive load that you have to do, it makes sense to set up the sort of the configuration for different target networks, and so you can use that. And so this you can set up the UCK config, and then that will allow you to set up the URL for the target network and the amount of fees you're going to pay, etc. And then you can use CK deploy from that. There's links there to a couple of faucets as well, if you need test Mina. Yeah, that makes sense. Okay, now in terms of development tools, I guess people are probably going to be continuing with what they are familiar with. So I think the majority of people are going to be using things like VS Code, or maybe you'll just be using a CLI, I don't know, but that probably is what people are more comfortable with. Because we're, excuse me, because we are, this is still quite early days, so I think we're going to see improvements in the tooling over time. Now, there is also, obviously, because we're working with TypeScript, JavaScript, then we've got, there is already tooling out there that can help us, but obviously then we also want more Mina specific things as well. So I think that is going to be happening or coming along. One very nice project that came out of, I think it was ZK Ignite cohort 1, is the Mina Playground. So you can use this. It's very good for tutorials. So you can work through it. Gives you a very nice environment where you can try out pieces of code, and it takes you through tutorials. And it's just altogether a very smooth, very pleasurable experience using that. But it's still being developed. So keep an eye on that. It's worth remembering that. And I think we looked at this a little bit last week as well, last session as well. Okay. Another thing I found, there's another repo that it uses Docker to spin up an online IDE that you can use as well. So there's a link to that. That's I'm not sure if that's still being maintained, but anyway, there's a link there to that. But I think with the tools, it's going to be really a case of you're probably going to continue using what you are comfortable with at the moment. Block Explorers, I'm sure you've used these. There's the normal Mina Explorer. Also, Monitor is very nice. If you haven't come across that, gives you lots of additional information, and you can do the normal searching for accounts, etc., and look at get all sorts of details. So there's a link to that as well. Okay, sorry, let me just look at Slido. Oops, sorry, let's do this on a different machine. Okay, it's still going to let me do that. Okay. Okay, I'll carry on anyway. So what I want to carry on with is, or look at now is, going to the more general case and looking at Mina use cases, and I think it's fair to say that we've become very focused generally in the blockchain world, looking at things like DeFi, and a lot of projects have been built, have focused on that. I would like to make the case, though, for perhaps looking outside that at times. And it's, to give you an example, I'll give you just an anecdote. I was at a hackathon in Prague where there were lots of DeFi projects, but then one team decided they went out into the city and they found pieces of land that weren't, the very small pieces of land, but that weren't obviously owned by anyone, little spaces between buildings. And then they put a little plaque in these pieces of land and said that this was now owned by a DAO, and they gave details of the DAO. And they just went around doing this, and that was their project. And I was very impressed by that it was a very creative thing. I think it had been influenced by an artist who had done something similar, but not to do with blockchain. But I was impressed by the sort of the lateral thought that they had given to that, and the fact that they had done something quite different. So I would urge you to follow that type of idea. Do try to think very broadly when you're thinking about the use cases, because I think it's very easy to get into the situation where we become very focused on sort of DeFi projects. Not there's anything wrong with DeFi, but I think it's generally speaking, people have become very focused on that and tend not to think outside that. And one way that it may be useful to help with this is that you can think, particularly with Mina, to think about the strengths of the blockchain. And really what sets it apart from other blockchains. And this is something I know I spoke about this a little in the last session as well, because I think, this is going to be really a theme perhaps throughout these sessions, is to try to keep this in mind and try to make the most of what Mina gives us, most of the features that we get. So, for example, the things like the fact that we have this idea of off-chain computation, which some other chains do have similar things, but it is still quite rare generally, this general idea. And this does open up, the fact that you're doing this does open up certain areas and does allow different use cases and allow you to look at solving problems in different ways that you wouldn't get in chains where you can't do that. The fact that we can have private inputs, I mean, this is part of the same thing, but the fact that we can have private inputs is very significant, and makes obviously starts to solve a lot of potential problems that other blockchains face. One big thing obviously is the around recursion. Now that you can look at that from in two ways. There's the general idea of recursion, that the succinct blockchain part, which certainly do be aware of that, and think about what that offers us. Then there's also the idea of the recursion in contracts, the fact that we can recursively create and verify proofs within our code. So both of those aspects are worth considering, and worth building on these special features of Mina. And the fact that this is a succinct blockchain, which also goes to mean as well, brings in the idea of the decentralization and the democratization that we have, which, when you're thinking in general terms of the types of projects you're building, I think these are things to bear in mind. Now, I appreciate that you've already started building your projects, and I'm not saying you should change direction now or anything like that, but just really for the future, I suppose. But also, there may be extra things you would want to add to your project that could be inspired from looking at these different areas. Now, I just pulled out a few use cases that are quite useful, but there are many, and I think it's worthwhile generally speaking to your people in the other people in the program about the types of projects you're doing. And I'm sure you are doing that. I can see on Discord that people are doing that, but it's certainly worth doing, and also looking at the other programs that Mina has been running, and looking at the types of projects there and the types of ideas that people have had. And just to pull a few things out. Sorry, I just need to try and log on to this to get my Slido back. Sorry, I'm having a few problems here. Okay, there we go. I managed to do that. Sorry about that. Yeah, so some very successful use cases, things like verification of private data, and I think maybe we'll try to look at some of these projects in a little bit more detail later on in the program. But there's all sorts of useful things that useful ideas here, where we have very much a need to be able to verify the correctness of data. But then you come across the problem that maybe that data has there are maybe some privacy concerns about that. So that, this is a very rich area, I think, that you could exploit. And there's lots of motivation for projects to be built around that. Similarly, with playing games where there may be limited information, and whether that is because you've invented a new game, which where you want the limit, whether you want there to be limited information, or maybe you've taken an existing game and then made that limited. I know there's people have done this with chess, where they you allow people to play chess but limit the amount of information about that they have about the other person's pieces. So there's again lots of interesting things you could do there. ZK oracles, this is a big use case, and you can I don't think I linked there to the documentation, but there's lots of documentation and videos about that whole area. And I think one of the reasons that there is quite a lot about that is because potentially that is it could be a huge benefit to blockchains. The idea that you can safely get data, that you can check the computation of that data. There's lots of interesting ideas around identity as well, and sort of the selective disclosure and privacy that you can explore. Also things around login as well, ideas, and I think we're seeing this generally in ZK blockchains. People are coming up with ideas of different ways of doing logging, different ways of doing email, and using zero knowledge to help them with that. And then one thing that is always going to be in demand is tooling for a particular blockchain. I think it's the case that as we get more and more blockchains, there's not always the need for every application to be replicated on every blockchain. That doesn't seem to make sense to me. But there's always going to be the need for tooling, such as block explorers, something like that. So when you're thinking about projects, certainly that is something that could well be useful. Or it may be that you find a deficiency in the tooling, and because of the project you're doing, and then that might inspire you to add something. So all of those things are going to be very beneficial generally for the community. Another aspect of privacy or the privacy of inputs that I hadn't really thought about before, but got pointed out to me, was the fact that if you look back to, or if you look at Web 2, or maybe sort of Ethereum, something like that, where everything is public, and you think about inputs to applications, and you know that these inputs are going to be public, then that will change your thinking about what is possible. And so if we move then to the idea where we can have private inputs, this does open up things around security, particularly. So you don't have to sort of have the same constraints that you would have thinking about security. if you have private inputs, that you maybe would have to introduce into an application where everything is going to be public. So it may be that you could see some application that is restricted because the security involved is restricting this application because it has to preserve some of the inputs. But if you then develop this on Mina, then maybe you don't get those same restrictions, and you could maybe open up that application or open up that idea a little bit more. And as I say, yes, it's a great opportunity to explore different ideas. I'll just come on to something. I don't want to be too negative about this, but it's just worthwhile thinking about. And again, this comes out of my experience of judging it at various events, and being part of different projects, and seeing many people building projects and then them not coming to fruition. So it's worthwhile bearing this in mind to give you the best chance to get your project done. People often are often quite ambitious when they start a project, and they may do something that is really just not feasible from, that could be because it's technically not feasible. There's just no way that thing could be done given the technology we have. So for example, we are restricted at the moment in the area of machine learning and zero knowledge. I'm not talking specifically about Mina here. I'm just talking more generally. And so there are some things that at the moment it is very difficult to do, but maybe over time this will improve. But it may be that you'd have to scale back your ambitions on that kind of project just because of some of the technical difficulties that exist at the moment. There also could be economic difficulties. The fact that maybe you want to create a stable coin, but the economics or the tokenomics or that anything around that area don't make sense or don't add up and wouldn't lead to a stable situation. There's also the idea of the economics of the project, I suppose, as well, and the idea that you could have a project that makes perfect sense and will work, but it just couldn't be scaled. Just wouldn't attract enough users for it to be viable as a commercial project. Now, that may not be a problem, and maybe you don't want it to be a commercial project, but these are things that you would need to think about, and you may need to change your focus as a result of thinking about these things. Also, a mistake that people tend to make as well is to start off very ambitious and to have a very large scope for their project, which they are not going to be able to achieve, which then leads to sort of motivation problems because you're not making you're not seeing progress. So it's always better to start off with quite a small scope and then add things later as you finish one part, and that will help your motivation, and it also may help you with the direction of your product as well. The experience you've had building one part may then help guide you in how you're going to build the rest. Another thing that should be thought about is people often, or people who look at starting projects on Mina where there's no real need for what Mina offers. And this comes back to what I was saying about the strengths that we have and playing to Mina's strengths. And so if when you're thinking about your project, really do think about are you making the most of the platform that you're working on and making the most of what Mina has to offer? And is it something that would work that really doesn't need Mina for your project? And often that is a reason for projects not really sort of living up to what they could do. Similar kind of thing, I suppose, the kind of boilerplate projects. We tend to see lots of projects being sort of copied from one blockchain to another, which I tend to think it can be something of a waste of time. Again, it comes back to the idea that Mina is very special. that has very special features, and so it's better to work to those rather than just to make a copy of something that exists elsewhere, because you're not, you're really not making the most of what the platform has to offer. And then there's the team issues as well. Can introduce problems. It could be the case that your team doesn't have enough experience in a particular area. As I say, often people are quite ambitious and want to do something very big, which is understandable, but they just don't have enough experience around that particular technology. I mean, maybe around, say, cryptography or machine learning, things like that. Also, something to be aware of is the issue of time. It is difficult to, if you're working in a, you have another job and you're doing this part-time, it is difficult to set aside time to do this. So do be aware of that, and make sure that you've got sufficient time to keep your project going. It is a great shame if you have to give up because you don't have enough time. Okay. So that was slightly, I didn't want to be negative. I'm just trying to sort of think of things to things to avoid, I suppose, and to hopefully will help you. So let's move on to some patterns that you may find useful. Ideas you may find useful. I sort of split this into ideas of patterns and then techniques. So the patterns are more general, and then techniques are, I suppose, a bit more specific. But anyway, so the first one, the idea of composability. So this is very widely used in DeFi. The idea being that you have a particular project that it does a certain thing. Maybe it's a decentralized exchange, or it's a lending protocol, or something like that, and then what you do is you allow these to be put together. So you have some data or some asset that you then sort of pass between all of these different projects that you're composing together, and so you end up with something that's maybe quite an innovative project, or sorry, innovative product, as the result of the way that you've composed these different projects. So it's certainly a worthwhile idea, a worthwhile thing to think about. And I'd say to advise people when they're doing hackathons, to do think about the idea of this. It is perfectly feasible as a to have a project which is really just putting together other building blocks that other people have built. It may be again, I know that you're already partway through, you've already started your project, but it may well be this idea may well be useful for you. It may be that that somebody else's project would be useful as a sort of an add-on to what you are doing, and you can sort of take existing code and make the most of that. So it's worth bearing in mind, and worth having a general idea of what else is available. We did cover this process generally last time, and I've got let me just put that on. I've got a link there to an example of this, so you can have a look through that. This is quite a simple example where you had a couple of contracts that were interacting with each other, and just doing some addition, I think it was, just to show you generally how this is done. Obviously, if you're doing this, with a bigger project, is going to be more complex. But that idea is worth bearing in mind, that you can compose things together. Okay. Now, the second pattern, we're certainly going to talk about this much more in the next session, which is going to be next week, I think now. But I will talk about it a little bit now, because it does solve a number of problems. Now, it's a big area, and I did speak about it a little bit generally with talking about the idea of the succinct blockchain. What I want to talk about here is more specifically about recursive functions and what this allows us to solve. So one thing that zero knowledge frameworks have problems with, especially well, when they're based on building or creating a circuit. Typically, if you have you're using some DSL that is going to be used to create that circuit, whatever that process is, there can be problems if that has some dynamic elements to it, and this is true. Excuse me. This is true generally, I think, with all the ZK frameworks will do have some may have restrictions around this. And one way that we can overcome this, and I think Mina does stand out quite a bit in this area, is the idea of using recursion. And recursion itself is obviously a general technique that is quite widely used. It's quite a neat way, I think, of writing functions or of create or building an algorithm, and you see it particularly in things like functional languages. It works particularly well, but the general idea behind a recursive function is that there is some type of base condition, which this base condition really tells you that you've hit the end of the recursion that you're doing. So if you think about maybe you're trying to loop through some numbers, maybe you're going from 10 down to 0, and if you're doing that, you want at each stage you're doing an extra layer of recursion, but you're going to have to finish this recursion at some point, and that is the base condition. That is the base part where it says what to do when you kind of reach the lowest part of the recursion, and then from that you can start to build back up. And then the other part of a recursive function is the step part, which is saying how does each step relate to the previous step, as how does the actual recursion part happen. Now, why this is, or the way that this is used in Mina, is the idea that it's not just a general kind of recursion that we're doing. It's the idea that we're recursively proving our code or our computation, and this is useful because it allows us to split up a piece of code, a contract, something like that, into parts. If there is some dynamic aspect to it, and it would be impossible to do kind of this computation all as one because of the restrictions we have around the circuit. What recursion allows us to do is to sort of split the dynamic part out into sort of basic steps that we can then repeat, and each part of this, because we're wanting to prove our computation, so each part of this, each recursion, we're creating a proof, but then that proof can then be verified as part of the recursion, and we can do the next part of the proof. And I'm sure this general idea is familiar to you. This is how we get the idea of the succinct blockchain, this idea of recursing proofs. But in addition to that, we can also do this within our code. So this is what this example here is doing. So we have the idea of the base case here, which is what to do when we get to this particular 0. We get down to 0, and then we have the step which shows us what to do between each recursion. So here we're adding 1 for that, which then calls back. Calls back. So that's the recursive part of it. And then the way that you would actually do the recursion is if you're then calling this, you can call the base case. So that's the with the 0 there, which will trigger the base part, and get the proof of that. And then we can use that proof as part of the input to our step method, and then we go to the next iteration. So here we're using 1, and then we take the proof from that and do the next part where we're passing in 2. So as you can see, the step function here, so the step method here is taking in the value, the 1 or the 2, etc., and then it also takes in as an input the previous proof. And obviously we need to verify that. So that's what we are doing here. We're verifying that the previous proof was correct. And so that means it's safe then to carry on and carry on with the recursion. Okay. So that's the general process. Yeah. And this is useful to be able to do this in our code because, as I say, it allows us to split things out when there's some dynamic aspect to our computation. We can split it into distinct steps, each one creating a proof which you can then verify and then go on to the next step, rather than trying to sort of build a circuit where we don't actually know what this circuit is going to look like because we've got this dynamic aspect to it. I've linked there to more details and to a further example. There's a good discussion giving lots of details about it, about recursion, and then this example is it does go through and show you how this happens. It brings us back to actions, and which I did say we're kind of going to. I did kind of avoid this area a little bit last time because there are some new ways of looking at this. But this anyway, it does show you. It is just another example of doing recursion and proving what you're doing. So that's just another example there for you. Okay. All right. Now the next pattern I want to talk about is it's a very general pattern, but it's featured quite prominently in a number of projects, and I very much like it. I think it's a kind of pattern that I like to keep at the back of my mind because it solves some use cases in quite a neat way, and it's a little bit difficult to explain because it is quite general and it could be used in all sorts of different ways. So one of the easiest ways to describe it, I suppose, is to say how it is used in something like Zcash, where the idea in Zcash is that we have UTXO, so we have what are called notes, which represent some token or some unspent token at least, and we want confidentiality about that. So we're trying to keep details of that resource, that note. We're trying to keep that hidden to some extent or obscured. But also we want to make sure that if somebody spends one of these, that they can't double spend. And so what we're looking for is a way that if we have a particular resource or asset, that we can have something to show that that resource has been consumed, or maybe a particular event has happened. But the nullifier pattern allows us to do this in a way that helps with the confidentiality aspect as well. So the general pattern that you have with this is that you have some resource, and then what you would probably have is there would be some obfuscation about this or some hiding of that resource for example, by using a hash of representing that resource or that asset, by taking a hash of that and using the hash within your program. But what you want to know is that you want to be aware when that resource has been consumed or spent, something like that. So what you do is you create a nullifier from this, and it's important that the nullifier is deterministic. So for that particular asset, you will always get the same nullifier, and so there is an accepted process of going from the particular asset, or maybe the hash of that asset, to a nullifier. And as part of the process of consuming that asset, what you do is you produce one of these nullifiers, and that nullifier, when it is produced, will then get stored, perhaps in a Merkle tree, but it will become part of the state of the system that you have. And so it is there as proof, or to indicate that a particular resource has been consumed or spent. And because there is a deterministic way to get from the original asset to the nullifier, what that means is that if you go back and you try to spend or consume this asset again, then you will create the same nullifier, and what you can do then is to check whether that nullifier already exists, and if it does exist, that tells you that that asset has already been consumed, or that token has already been spent. But because of the obfuscation that is going on, we can check that something has been spent, but there isn't. If you see the nullifier, you cannot then go back and work out which asset this refers to. So the process is very much one way. As we're spending that asset, we're creating a nullifier, we're going through this deterministic process, and then we can check whether that nullifier already exists. But for somebody else, if they see a nullifier, they wouldn't know which asset that represented. So it's a way of adding confidentiality, and so that's why I say it's a pattern that is widely used in systems such as Zcash and Aztec. Tornado Cash use it on Ethereum. So it's a very nice procedure, but it can be useful quite generally as a way of breaking a link or making a link very much one way. So in that sense, it can be quite a useful thing to bear in mind. And there's an example there that I can show you. I think this one is from it's a voting contract where the idea was that I suppose you want to make sure that a vote hasn't already been cast, so that the vote can only be used once, but you want some confidentiality. You don't want to be able to see how somebody has voted, and so you have this. I forgot where it is now, but somewhere in here you have this idea. Yeah, here you go. So you have this method which is there to make sure that this vote hasn't already been cast, but also we're not giving away, too much information about the vote. Sorry, I have to plug my laptop back in. Go. Okay, so there's an example there, but this, as I say, that's just one example. This pattern generally is, I think, quite useful. It may solve some problems that you have. It's because of this, this one-way aspect of it, but also the fact that it's quite easy, particularly if you're using something like a Merkle tree. It's quite easy to check for the existence of a nullifier, so you can detect that. The question on Slido, when using, how do we ensure that the nullifier is legitimate and the most recent version? So that has to come from this deterministic aspect, that the way that from that particular asset, you can only produce one nullifier. And so whatever process it is that you're doing, that process will always deterministically produce exactly one nullifier. It relies on the fact that we don't have a hash collision. Yeah, that's I think that's, hopefully that answers your question. Now, obviously, that asset could have a number of features. You could put other information in that, which would then be part of the nullifier. But the idea is that the same deterministic process would be used, so that you would always get the same nullifier for a particular resource or item, something like that. Okay. All right. Another idea that came across, and I should say, yeah, Mina NFT project had loads of useful patterns, and that I'm quoting them in lots of places. So many thanks to them for this. It's the idea of stateless contracts, which is, well, I suppose you might think it's an unusual idea, because typically we want to change the state of our contract, but if you follow this through, and you can look at the discussion and the problem that it solved, the idea is that obviously you can, when you're writing a contract, it's up to you what state you're going to have in that. You don't have to you have state variables, so you could just have methods in there. You can also have non-state variables, so things that aren't going to be verified as part of the state. And the reason why this was useful, I think, is that it's moving, or it helps us with the problem that you have, the problem of the synchronicity, and ensuring that we're getting our state updates done in the correct order. So we're very familiar about checking the state before we're making an update, and checking that the state that we have is correct. So this is really bypassing that. We don't, this allows us to be much more confident about what we're doing, because we don't have any state to check there. So it's almost like going towards more of the idea of a library, I guess, where you just have some methods that are doing some functionality. But it's worth, I don't know whether that's going to be a useful pattern for you, but it is something worth bearing in mind. And as I say, I've got links there to the various discussions. So the question from Hemant, could ordinals be a kind of use case of stateless contracts? Thank you for that. Actually, that's yeah, I think it's very interesting. Ordinals and inscriptions, as they became on other chains. So ordinals came out on Bitcoin, and we got the idea of inscriptions on other chains. Became very, very popular indeed. There's been a lot of hype around them, and a lot of transactions done on chains around this idea, and they depended upon, or they came about because of the limitations of what was possible on Bitcoin. And so you got data being passed within data being passed within transactions, where the actual state would then get stored, maybe picked up by other third parties. Now, on different chains, this happened in different ways. But yeah, this idea, I could see people doing something similar. And although it is a little bit different, because with Mina having off-chain state, that does help with a lot of the problems that led to ordinals and inscriptions coming about. But I suppose people may do something similar, and you could get, you could have this idea of a stateless contract that is defining some asset, or some be involved in inscriptions maybe, and the state of that maybe is not stored within the contract itself, but could be stored, or instructions about it could be as part of the transaction, or even just, I think in this case we had where they were getting many transactions into one block, there was a nonce being used, and really that is the idea of an ordinal as well. That's where the kind of the ordinal, how the ordinal was being used. It was just an increasing number that implied some rarity. So yeah, I think there's all sorts of areas to explore there. Although again, because of the way that of what we have with Mina, there's perhaps it is perhaps a little bit different to what we would see on other chains, because there's perhaps less need for that. Yeah. Okay. Oh yeah, sorry, but yeah, what I was leading up to was the idea, the reason for the stateless contracts was to allow to allow many transactions in one block, because if it is stateless, then you're not concerned about the ordering of those transactions, and you don't have to be aware of any state updates. You can just, each transaction is quite happy to be a sort of any point in the block. So yeah, I think that's the purpose for that one. Okay, now a question that was asked, I think it may have been on Slido, I can't remember, but people are asking about the difference between programs and the ZK program and the contract, and this very simple difference is that contracts perhaps have more functionality because they are tied into a blockchain, so they have to be aware of the context of the blockchain, whereas a ZK program is much simpler. I mean, this is very much the heart of what is being done, where we're doing some provable computation, but the ZK program is not making any assumptions about the context where this is being done. So the ZK program itself could be being run and have no relation to any blockchain whatsoever. It could be just, you could just have the ZK program, which is creating a proof without caring about what's happening on the blockchain. But when you want to get that involved with the blockchain, that's when we introduce extra pieces of functionality, and that's where we then get a contract. So yeah, that's the easiest way to think about it. The ZK program is simpler, less assumptions. A contract is also adding in the details of the context and the running in the context of a layer 1 blockchain. Okay. The questions on Slido: actions and reducers, can't we have many transactions in one block? Yes, so again, that's another way to approach this problem of getting the sequence of updates correct, is by using the actions and the reducers to go through that. Is it possible to have a status contract emit event logs and use the logs later as data? Yes, I guess so. I think this idea, this statelessness, is not how can I say? It's not very hard, a very hard definition. I think it's just the case that the way that the contract was written, they were not using state variables, and so they could then run many transactions together. But I don't think it's anything that is very there's a very sort of hard definition about this. So I think there's a lot of leeway about how you can do this. And in fact, I mean, this fact that they have this idea of non-state variables is kind of pushing that a little bit. So I think the idea then that in Slido, the question about emitting events and using that as a way of producing state is true. And also, when you do things like that, then you introduce the idea of these, this being picked up by third parties. So when if events are emitted, then the data that's involved in those can then be picked up. And it may be the case that you don't need that state to be in the contract. It could be the case that you can pick that up from the events and store that elsewhere, and that may be a perfectly valid thing to do. Okay. All right. And sorry, yeah, the go back to the contracts or programs. Yeah, there's more details, much more details about the differences there. It's a very nice discussion to help you with that. Okay. Another thing, just to be generally aware of, I suppose, is be aware of what needs proving in regard in your computation and what doesn't. Now, that is it's a little bit abstract, I suppose, to say that. And one way that helps me think about this, I go back to one of the sort of classic examples of ZK, the idea of a Sudoku puzzle, and the this if we build something like that in zero knowledge, what we're usually building is something that proves that the results of a Sudoku puzzle is correct. So we're proving the correctness of an answer to the puzzle. We're not actually proving that. Oh, sorry, we're not concerned with how that answer was derived. So you could have a project piece of code that has two aspects. One is something that is going to solve Sudoku puzzles, but you don't need to prove that itself. You don't need to prove that's being done correctly. You're really just concerned with the answer it comes up with, and then you taking that answer, what you're proving is that the checking of that answer is correct, and so the proving part of your code is checking the answer, not how you came up with the answer. So do think of that distinction when you're building your project, and can you move things out or other things that don't need to be proved, because it can be an optimization if you can take things out. Having said that, do also be aware of under constrained code. So do make sure that you are testing everything that you need to test within your code. So don't allow someone to produce a false proof, or produce a proof that would be accepted, because the checking of that the claim that the prover is making is not constrained enough. So it's really just a question of being very clear about what it is you're trying to prove, and then just exactly testing that. Okay. Yeah. Yes, thank you. The compiler should. Yeah. Thank you for that comment. Okay. Moving on. Just going through some other techniques. This is really just a random set that just some random techniques that I thought you may find useful. This one here from O1JS pack, the idea that we can pack variables together, and so because we know we are limited to the amount of state that we can store within our contract, and if you, for example, you don't want to use up your slots, or necessarily use up all your slots if you're just to store just one bit, for example, with a Boolean, something like that. So it makes sense to put together the state, to pack together state into one slot if you can, just to give yourself more available state within your contract. So that's what this does. And there's an example. So let me find it. I don't know if I can open that. This test, I think, shows you an example. It goes through. It goes through taking a large string, I think, and then packing this down with some other strings as well. So you can have a look at that and see how that works. Okay, so you can pack and unpack. Obviously, you get the advantage that you're getting more storage available to you. But the drawback for this then is obviously this extra computation that you're doing by packing and unpacking these items. So there's a trade-off. Another thing that I came across here, just if you, again, thanks to Mina NFT, checking if an account exists, some code here that can show you how to do that. That I think is something that is probably going to be quite useful to people generally. Time restrictions. So there's a link there to some examples of this, and this relies on this next part, actually, this context from the network. So this is quite a common situation, I suppose, that you would want to do something, or something may be valid within a certain time frame, and you want to be able to check that. So there's lots of good examples around that. Now, time and date support, also in JavaScript, there's lots of support for those concepts generally, but then added into that, you do need to be able to get these details from the network. So that's what all this is about. So it's getting things like timestamps, but also other things that you can get, such as the block height, the total amount of Mina, etc. All sorts of useful things. Things like the number of slots are useful as well, because or you could use the block height. It's often a neat way to look at time passing by looking at the number of blocks or the number of slots that have happened since a certain time. So yeah, so you can see lots of details there, things you can get. So that's that. Another useful thing, if you have a file, this is sort of a general piece of data, just as it is, that you want to get a commitment to, a way of doing that, you can, or the steps that you should follow for this is you can create a hash of that data off chain, and there's a link there to an example of doing that. But then if you want to do this correctly, what you need to do then is to create a hash of this hash, and do this verifiably, and then store that result on chain. And this, you need to do this extra step, because otherwise, if you're passing the hash of a particular piece of data on chain, people could they use that to claim that they have this particular piece of data when in fact they don't. And so we want to make sure that we want to verify that if somebody is doing this, that they need the pre-image of the hash that we're going to store, and that pre-image is the hash of the big piece of data that you've got off chain. So it's just an extra thing to think of, or an extra step you need to be aware of. You need to verify if you want to go through that process. Now, I mentioned that I mentioned interoperability, and it is the case. We are, I think, moving to the situation where we're going to have much more interoperability. We want to be able to talk to other blockchains. Maybe we want to deal with assets from other blockchains. We've seen that the signing algorithm has been integrated. There's also some details then here of dealing with addresses. So obviously on Ethereum they have a particular format. So if this is showing you, this is not the contract code. So this is showing you how to do this using other third-party libraries to do that. But you can fit, Ethereum addresses are smaller than than they could be, I suppose. And so we can fit them into a field quite safely. Okay. Now, I'll just very quickly, maybe I'll just finish on this item. A very interesting, very clever, very creative solution that came out. You can look at the discussion here, and the code example was where somebody, sort of quite a bit of lateral thinking, I think, and they had the idea of using a token balance as storage. So if you do, obviously you can set up a program to create the balance of a token to be whatever you want, or you can mint, any sort of value that you want. And so that flexibility then allows you to use that, not to represent a balance as such, but to actually represent something else. Now, obviously, it only makes sense within the context of how you are using it, but it is certainly possible. And so, sorry, I've forgotten which link I'd opened there. So there's an example in this code. In this particular, I think this is a game where they were looking to, they wanted to ensure that something happened. I think it was something happening after a particular time, and so they were effectively using a token. I think this bit at the end here, they're effectively using a token amount as a kind of a timestamp, and sort of because we know how a timestamp works, it's always going to be increasing. Then we can model that by using a token balance and adding to a token balance. And so you can take something that is available, on a token, which is its balance, and then use that for other things. So quite a clever idea, I think, quite a clever little trick. But yeah, have a look at the discussion about that as well. So I'll just quickly finish off with other things. Metadata about your contract. You can see, you can use analyze methods to see details. But this is particularly useful if you are thinking about the size of your circuit. This can give you details about that. So that's what that is. And then also I came across this alternative to GraphQL. So it's an API that you can use to then query data from Mina. And so this is going to be useful, as it says here, particularly for things like explorers or wallets, etc. And then that's it. So just got some links there to useful resources, just to put those in the notes so you've got them all in one place. All right, so I think I'm out of time, so I'll finish there. Thank you very much for your attention. I hope that included some useful techniques and some useful ideas. We'll meet next week, where I'll be talking about recursion. So I'll be revisiting recursion. We'll go into more detail about that. And I'll probably be going through more techniques as well. So I'll finish there. If you have questions, please put your questions into Slido. That's the best place for them, and we'll get some answers on that. Thanks, everyone. I wish you rest of the day. I hope you have a good day and a good weekend, and I'll see you next week. Thanks, everybody. Bye-bye.
Thank you so much, Lawrence, and yes, see you guys. You can ask your questions to Lawrence on our Discord channels. So be there. Let's meet there. See ya. Thank you, Lawrence, again.